now that you have obtained your D prime scores for whatever experimental condition that you ran, I'd now like to show you how to present this data in bar graph format so that it's suitable for presentation, and also to run basic analyses, basic inferential statistics on them. So hopefully you have watched the previous video and learned how to calculate D prime scores from for individual subjects. So here we have individual subjects represented in rows. This is their D prime score for their first run. This is the hits for the first run, false alarms, and the D prime score. So I'm just being a bit repetitive. So what you do is you basically open up GraphPad. So say for example, new project file, and you say you want to create a new table and graph. So one easy way to do this would be to actually see the sample data that was used. So here I'm using GraphPad 6. If you download the GraphPad trial version, it will most likely give you GraphPad 6, which is why I'm showing you there. But GraphPad 5 should also have quite similar setup. So you just go new and then you sample data paired, and then you just say you'd like to create. And here's some sample data. So you can go ahead and delete this sample data and insert your actual data. So here our first condition that we're interested in is the sham run, which was the first run. I'll just delete these cells. And then the second run was the actual TDCS one. So you just put in stimulation, and so in this case, here is the first run with the sham. That's your D prime scores for subject number 79. That's his or her score. So what you do is just copy that, paste that in to your sham column, and then you have your second column here, which are D prime scores for the stimulation condition. In this case, this is cathodal, cerebellar cathodal TDCS, and you go ahead and copy those. Obviously you have to really make sure that the columns correspond, because these are paired t-tests, so the same subjects must be presented in every single row. So you need to make sure when you are checking your data, you need to make sure that every single row corresponds to each other. So this corresponds to this corresponds to this, and so on. So I have already done that. And then the next thing you do is analyze that data. Actually the next thing you do is a nice thing to do would be just to label the actual rows. So you just paste those values in. So the subject number 79, 80, blah blah blah, 90. So you hit analyze, and then you would it will ask you which data sets you'd like to analyze. So these are built-in analyses. You go column analysis, t-test, sham versus stimulation, and then you say you'd like to use the paired t-test. Say yes, okay. And then you have other options here in the second tab. So you can use one-sided or two-sided. We should be using two-sided because it's more well accepted, although we do have a priori hypotheses, so it's actually okay to use one-sided, but two-sided is less controversial. So two-sided, and then you can say report differences as stimulation minus sham. So what it's going to do is just do that calculation for you, graphing options, graph differences. So I'm pretty sure GraphPad 5 doesn't always have these options available. One thing that's very useful is to have the descriptive statistics up for each data set. So tick that, and you're ready. So 3 significant digits are usually enough. So here's the set of data that is now available. So we can see that the p-value was nearly significant. P equals 0.072. So if you had one-sided, this would actually, so let's just show one-sided t-test, this will actually show as significant. So basically having your t-test either one-sided or two-sided essentially changes your p-value like that. So it's a little bit more controversial to use one-sided t-test. So now that you have your p-value, you should go and generate your graphs. So GraphPad should have already created some graphs for you. So the first graph that GraphPad created is likely to be this before-after graph. So these are individual subjects represented in dots, and we can see what the effect is on their data. So if you look closely, you have one subject who is performing near ceiling. It's 3.667. That's probably why you don't have a significant result. Subject number 83 got all stimuli correct. So I'm going to go ahead and exclude him and see what that does to the data. So if you look at that, that's probably what's happening. So if we collected more data, this difference is likely to become reliable. It's really driven, this lack of significance is really because that one subject had perfect scores, and therefore the stimulation couldn't do much in changing his performance because he was already perfect, so he couldn't be improved anymore. And I have actually seen papers where they exclude people whose performance was already at ceiling. So this gives you this sort of before-after graph. What's more traditional is to have a bar graph. So you hit new data table, or you could just hit new new graph of existing data, and then you would probably go this one, grouped plot summary data, I think. No, I'm wrong, sorry. Sorry, so I was almost right. So you select, the type of graph was column, and for some reason it automatically selected this pattern, this